In most cases, when you compute NPV, that is net present value, and internal rate of return, IRR, you usually get the same solution. But that's not always the case. And so I want to show you an example of that right here. So I have two projects, Project A and Project B, and they both cost the same, but they have different cash flows. You'll see that the cash flows for A come later in the project. The cash flows for Project B come earlier. And if you calculate the NPV and the internal rate of return for both of these, you'll see the NPV for A is $23.33. It's $19.98 for Project B. So using the NPV criteria, A is better than B. If you calculate the IRR, it's 20.24% for A and 23.56% for B. And so B would be preferred to A using the NPV approach. Now let me just note something. When I calculated the NPV, I used a weighted average cost of capital or an interest rate of 10%. Now, you have these conflicting decision rules. Choose A because of NPV, choose B because of IRR. Now, we know that actually NPV is the best method and you should use NPV if there's any conflicts. But where are the conflicts? And how can we use IRR if we still want to use IRR as our approach? This may be a better approach. You have to keep in mind that when you are communicating the ideas of which project to do, everybody you're communicating with is not necessarily an MBA in finance. They may be someone who has less experience in finance, and it may be easier for them to understand the concept of one project returning more than another. So how do we do that? Well, we can compute something referred to as the crossover rate, and I'll show you in a second with a graph why we refer to it as the crossover rate. But what you do is you take the two projects and you subtract one from the other. So I've taken A and subtracted B from it. So 100 minus 100 is 0, or minus 100 minus 100 is 0. 15 minus 70 is 55. The cash flow for year 2, or the difference between 60 and 50, is 10. The difference between 80 and 20 is 60. And you calculate the internal rate of return for this new set of cash flows. So if you put this in as the cost, and you put this in as the first cash flow, second cash flow, third cash flow, and you calculate the IRR, you get 13.93%. And that's what we refer to as the crossover rate. That's the point where you go from A having a higher NPV to B having a higher NPV. So just intuitively, let's look at these numbers here. In the case of A, you get most of your money in year 3, okay, farther out in the future. In the case of Project B, you get most of your money in year 1, close to the present. So this is the case where a higher interest rate is going to hurt A because that discounting factor, dividing by 1 plus the interest rate raised to the third power, is going to really reduce this number much more than it's going to reduce this big number. And so the crossover rate is where the two are equal in terms of NPV. So at an NPV less than 13.93%, A is better. At an interest rate higher than 13.93%, B is going to have the higher NPV. So how can you actually visualize this? What you can do is you can construct something referred to as the Npv profile. And the Npv profile just relates the net present value to the discount rate, or the weighted average cost of capital. And I've done that here. I've computed the NPV for A and the NPV for B at different interest rates, starting at 0, and I think I went up to 30%. And you just put the formula in, and so I put this in, so I had it so that this interest rate would change no $sign in front of the 15, but I have these cash flows in here. And you'll note that if you don't know already, the NPV function in Excel and all the other spreadsheets doesn't actually calculate NPV. It calculates the present value of the cash flows, so that it starts discounting with the first cash flow. So it must be the case that whoever wrote the computer code for this the first time did it incorrectly. So when Excel was first created and whoever created this function, they did it incorrectly, and they've continued to do it incorrectly because they want future generations of Excel to be compatible with previous generations of Excel. So they're always wrong, and it's true of OpenOffice and LibreOffice and some of the other Office suites. So this is sort of the standard. So you just have to take note of that. So how have I done it? I've calculated essentially the present value of the cash flows from C7 to C9, and then I've subtracted out the cost of 100. And I did that for both A and B. And if I scroll down here, you'll see I actually drew what they refer to as the Npv profiles. Okay, I graphed this, and you can graph this by highlighting all the cells and then choosing Insert, and this is going to be a scatter graph. And you would choose the scatter graph of the lines crossing. So the reason they refer to it as the crossover rate, because that's actually where the points cross. And at that crossover rate, the net present value for both A and B are exactly the same. To the left of it, you'll notice that A, the blue line, is above the NPV of B, the net present value profile of B, which is this red line. To the right of that point, you'll notice that B is above A. So this is the case. So it depends on what the weighted average cost of capital, or what the discount rate is, in terms of which one of these projects is going to be better. Now these are mutually exclusive projects, so if you do one, you can't do the other. You have to make a decision. Let me point out one other thing since I drew the NPV profiles. You can also see where the actual IRR is, and that's where it crosses this zero axis, because internal rate of return, in fact, is the interest rate that makes NPV equal to 0. So I believe this first one is something like 19.98%. Let me just scroll back there and we'll take a look. Oh, I'm sorry, it's actually 20.24, was 19.98 for the NPV of B. And the other one is 23.56, and that's where it crosses this axis. So the crossover rate is the appropriate way to compare the IRRs of two projects, assuming that they're mutually exclusive.